Today at FlightSimulationGuru.com, I'm presenting a brief overview of my own home cockpit project. For a more detailed description of the project and an ever-growing collection of reviews and how-to videos, be sure to visit FlightSimulationGuru.com by clicking on the link in this video's description. The overall goal of this project was to build a custom system for replacing the cockpit displays in Microsoft Flight Simulator and also provide input panels to replace keyboard commands for controlling aircraft systems. One can purchase a variety of prefabricated button and switch modules for Flight Simulator. However, these systems aren't cheap. Also, I decided to build my own custom cockpit from scratch, both to ensure that it's fully customizable to my needs and, of course, because it's always a lot more fun and rewarding to build something yourself rather than buying it off the shelf. At the moment, the primary view display is a 24-inch LCD monitor, although I plan on replacing this with a much larger LCD projection screen at some point in the future. The panel itself consists of over 30 different switches and buttons for controlling all of the aircraft systems and navigation equipment. The overall layout of the panel is modeled after a Boeing 737, however I made a number of significant alterations to suit my own personal preferences. All of the switch panels are backlit with amber-colored lighting to allow for easy operation at night. Some of the switches also feature additional backlit status lighting. For example, this display illuminates a red parking brakes indicator when the parking brakes are activated. And the landing gear display also features notations to indicate when the landing gear is deployed. The primary flight control input is a Saitek ProFlight yoke. Throttle, spoilers, and flap controls are provided by the 3-axis control unit that comes packaged with the yoke in the ProFlight system. Rudder and brake controls are provided by a set of flight pedals, also from Saitek. Finally, the Z rotation axis from an old Sidewinder joystick is currently being used to control the nose wheel steering whilst taxiing. The foot pedals can also be used for steering, as is the case with some small aircraft, but the additional joystick provides an input closer to that found with the hand crank steering input on a commercial jet. All of the flight displays are provided by a combination of Flyware's FS Expand and FS Client suite. FS Expand, working in conjunction with Peter Dawson's FSU IPC, functions as a server to distribute aircraft gauge readings and system information across a standard computer network. Other computers on the network can then run another program, called FS Client, to receive this data and display it in the form of navigation displays and electronically generated gauges. The displays and gauges in my cockpit consist of 2 LCD flat panel monitors positioned behind strategically placed openings in the cockpit structure. All of the aircraft systems are covered, including the autopilot, radios, and navigation gauges. This allows for the primary display from Microsoft Flight Simulator to be fully reserved for showing the out-the-window view without any on-screen gauges or panels. The entire cockpit setup was built with wood and then painted a grey-blue color to resemble the painted metal panels of the Boeing 737 cockpit. Wood is much easier to work with than metal panels and is my material of choice for cockpit building. Here you can see the rear of the main cockpit display with the 2 LCD panels and wiring for many of the switches. The switches interface with the Flight Simulator computer through a keyboard hack using the controller chip from an old keyboard that I had lying around up in the attic. The controller board was removed from the old keyboard with the original key inputs removed and replaced with a terminal strip that simplifies the process of making connections from all of the switches around the cockpit. Check FlightSimulationGuru.com in the future for a much more detailed description of how this chip was integrated into the project, but briefly, the controller chip translates a simple signal pulse from the terminal strip into a single keystroke. This setup works fine for a momentary push-button switch. However, many of the controls within the cockpit are toggle switches that operate in a constant on or off state. This presents a challenge because flipping a toggle switch would produce a constant signal rather than a pulse, and would be equivalent to holding down a single key on the keyboard. To get around this issue, simple relay circuits were wired up for each toggle switch, consisting of a reed relay and capacitor, to produce a pulse of a few milliseconds each time the toggle switch is flipped on or off. These circuits are powered by a separate 9-volt battery. and therefore it's very important that the circuit is wired up correctly, or else the voltage from the relay control circuit could damage either your controller board or computer's motherboard. Finally, the backlighting for the panels is provided by amber LEDs positioned behind each panel. In the future, I will also be producing a much more detailed guide for how I built my panels using inexpensive materials available from your local hardware and office supply stores, so be sure to check back at the website again soon. Well, that's a brief overview of my setup at the moment. I will be producing more updates in the future with a lot more details for each of the setup systems and design elements, so be sure to check back again soon.